Today we're going to finish chapter 4 with triangles and coordinate proofs. And what a coordinate proof is that you're going to be using figures in the coordinate plane and you're going to be using some algebra to prove geometric concepts. The first step to be able to do this is placing the figure on the coordinate plane. And here's the catch, is that when you are doing coordinate proofs, there are actually not numbers that you're using. You're going to be using letters. So here's an example of what you're going to be doing. It says position and label right triangle M and P. Okay, so this is key. We know it's a right triangle, and those are the vertices M and P on the coordinate plane. So that leg MN is A units long, and leg NP is B units long. So first of all, you got to know what the legs are of a right triangle. The legs are the two sides that form the right angle, and then the third side would be the hypotenuse. So one thing that's important here is that the name of the leg. So one leg is MN, one leg is NP. So notice that N is my repeated vertex, which means N is going to be the vertex that both legs have. One suggestion anytime you're doing something on a coordinate plane is anytime you can use the origin, do that because it's going to make it easy. So I'm going to put the origin, and because it's going to be, if you notice, the y-axis and the x-axis automatically form a right angle. So I'm going to have that in that's repeated be here, and this would be the point 0, 0. And then it doesn't matter which way I go. Let's just say this would be M up here, and we'll put this as P. And then I'm going to connect these dots here. Okay, so I have my triangle. I need to finish out by putting the coordinates of M and P. So I hope that you're seeing you have a right triangle, you have legs MN and legs NP. Now we want leg NP to be, or let's start with leg MN. We want leg MN to be A units long. So that means this distance here needs to be A units. So I want you to think about it. If I said I want that leg to be 5 units long, then if N is at 0, then M would have to be up here at 5, right? And if it's on the y-axis, that would be 0, 5. Or if I said I want it to be 3 units long, M would have to be 0, 3. In our case, we want it to be A units long, so this would be 0, A. On the other end, we want leg NP to be B units long. So the same concept. If I want this distance to be B, if I said I wanted it to be 4 units long, then this point right here would be 4, 0, because if it's on the x-axis, you know your y-coordinate is 0. If I said I want it to be 6 units long, that point would be 6, 0. In our case, we want it to be B units long, so this would be B, 0. And now I have placed my right triangle on the coordinate plane. One leg is B units long and one leg is A units long. And so we have found the coordinates of those points. Okay, let's try this one. This time, we're going to position and label isosceles triangle JKL. So here's what we're drawing on the coordinate plane so that its base JL is A units long, vertex K is on the y-axis, and the height of the triangle is B units. Okay, so a couple things. They tell us the base is JL. They tell us vertex K is on the y-axis. So somewhere on my y-axis, I'm just going to put it here, is my K. That means J and L have to go on the base. And to make things simple, you want to get things on axes as much as you can because those are the easiest points to find. So I'm going to put J and K equal amounts away from the origin. So here will be J and here will be K. You could have mixed that up. Oh, not K, sorry, L. And you could have had L on the left and J on the right. It doesn't matter. So I'm going to connect these points, and then we're going to work on finding the coordinates of these points. Okay, so they told us this was an isosceles triangle, so let's go ahead and mark that those sides are congruent. Now, what they told us is that the base JL is A units long. That means this total distance is A units. And sometimes it's helpful, that's what I was saying on the other example, sometimes it's helpful to think about this using numbers. So if I told you that the base was supposed to be, let me just draw a picture over here. So let's say this is our triangle here. Whoops. Okay, if I said I want the base to be 6 units long. So here's my axes. This is kind of a bad picture, but you get the drift. So if I wanted my base to be 6 units long, if this is an isosceles triangle, that means this distance is the same as this distance. That's the only way it can be an isosceles triangle, right? For these sides to be congruent. So if it was 6 units long, then I know this direction would be 3 units. This direction would be 3 units. So J would be the point -3, 0. That's why it's nice to be on an axis, because one point would be 0. And L would be +3, 0. Okay, if I said I wanted my base to be, let's say, 9 units long, then I cut 9 in half. This distance would have to be 4.5, and this distance would have to be 4.5. And so my points would be -4.50 and then +4.50. So when you're dealing with an isosceles triangle, you need these distances to be the same. So whatever the length of the base is, if you cut that in half, that's the distance we're traveling. So if I cut A in half, I'm traveling A over 2, or 1/2 A, or this direction I'm going A over 2, or 1/2 A. So that means my points, this one would be negative A over 2 because my X value is negative when I go left of the origin, and my L would be positive A over 2, 0 because I'm in the positive direction. So when you have an isosceles triangle, you need those distances to the left and to the right of 0 on your base to be equal. They have to be equal for it to be isosceles. The next piece of information is that we want the height of our triangle to be B units. So it's important to remember when you're finding the height of the triangle, the height would be the perpendicular line to the base, which would be this distance here. So we want that height to be B units. So if I'm traveling at 0 up B units, no different than I said if I want the height to be 6 units, if I wanted the height to be 6, I'd put K up here at 6, which would be the point 0, 6, right? Because on the y-axis, your x coordinate is always 0. We want it to be B units. So this is going to be 0, B. And now I have my figure in the coordinate plane with all the vertices labeled. Okay, so here's just some steps in how you can place something on a coordinate plane. Use the origin as a vertex if you can, or use the origin as the center of the triangle. So we did both. On the first example, we used the origin as a vertex of the triangle. That was your in right here. And then on the second one, we used the origin as the center of the triangle. Place at least one side of a triangle on an axis if you can. We've been talking about that. Keep the triangle within the first quadrant if possible, which we were able to do on the first example. And then you want to use coordinates that make computations as simple as possible. Okay, so let's look at this one. Name the missing coordinates of isosceles triangle XYZ. So we know that this is an isosceles triangle. Let's start with x. We know that x is at the origin, so that's 0, 0. Okay, then we have y and z. And you might be able to hear that over the speaker, so I'm just waiting a minute. Okay, so z, if you notice, z has a coordinate a, and that's the x coordinate, right? So when you're sitting on the x-axis, whatever that x coordinate is, if you're starting at 0, that's the distance that the base is. So if z was the point, let's just make it up. Let's say z was the point 8, 0. If z was 8, 0, then this distance would be 8. Because if I start at 0 at the origin and I go all the way over, I'm going over however many units that x coordinate is. In this case, it's a. So z is a comma. If it's on the x-axis, you're not going up or down, that makes your y coordinate 0. Okay, now this is what we have to remember. The vertex, which is up here at y, of an isosceles triangle is always, remember this is what we were talking about earlier, means your base is going to be cut into 2 equal parts there. So this right here is the halfway mark of that base. So if my base is 8 units long, let's pretend numbers. If my base were 8 units long, then the x coordinate right here at the halfway, or at my vertex, would be 4. Okay? So up here, my y coordinate, or I'm sorry, my x coordinate for y would be 4. If my base were, let's say 13, then the x coordinate of my vertex would be whatever half of that is, which would be 6.5. So I hope you're seeing that if you have an isosceles triangle, your vertex has to sit at the halfway mark of the length of your base. So let me get rid of this 4. So if the length of my base is a, then half of that would be a over 2. Or you could also write that as 1/2 a. So my x coordinate would be a over 2. And then your y coordinate is just whatever the height of your triangle is. And they don't give us any specifications about what the height is, so we can go up as high as we want to. It doesn't matter what it is. You can pick any letter. I'm just going to pick B. So the coordinates of my y would be a over 2, comma, B. There are no restrictions on the height, so that's why my y coordinate can be any letter I choose. You could have said C, D, X, Y, etc. So the biggest thing on this is knowing if it's an isosceles triangle, your vertex sits at the halfway mark of whatever the length of your base is. Okay? So let's try this one. Number 2. Name the missing coordinates of isosceles right triangle ABC. So we know that this is a right angle, and then that means these two sides are congruent. Okay, so we have A, we have B, and we have C. So B is at the origin, so that's our easiest one. So that's the point 0, 0. Now C, if you notice, C already has one coordinate in there. It tells us that our x value is A. It's sitting on the x-axis, so that makes our y coordinate 0. Now, if you go to point A is on the y-axis. So remember, if you're on the y-axis, you don't go left to right, so your x coordinate is 0. Now, here's the deal. Because these two sides are equal, they have to sit the same distance away from 0. So if you notice the length of this, I start at 0 and I'm going over to whatever this x value is, and that x value is A. So that's a distance of A. That means I need to do the same thing on this leg. I need to go up a distance of A. So if I want to go up a distance of A, that's a y coordinate of A. because it's isosceles, they have to have the same coordinates because it has to be a distance of A from the origin. Okay, now we're going to look at how we would write a coordinate proof when they're giving us information. So one of the things about a coordinate proof, for the most part, you're just going to do the work and then you're going to be able to say this is why it's true, why the proof works. So we have write a coordinate proof to show that a line segment joining the midpoints of two sides of a triangle is parallel to the third side. So the triangle is already set up for us. So here's what we have. We have triangle given ABC. S is the midpoint of AC and T is the midpoint of BC. What we're trying to prove is that ST is parallel to AB. Okay, so we're trying to prove that. So here's what you need to think about. If I want to prove that lines are parallel, think about what's true about parallel lines, and that is that their slopes are equal. So if I can show that their slopes are equal, then I can prove that the lines are parallel. So to be able to show that their slopes are equal, I need to find the coordinates of point S and point T. Okay, so to do that, S is the midpoint. So we're going to use the midpoint formula to find S. So the midpoint formula is, you're going to take your X values of C and A, so that's 2B plus 0, and we're going to divide by 2. Then we're going to take our Y values of C and A, that's 2C plus 0, and we're going to divide by 2. So I would get 2B over 2, comma 2C over 2, and that's going to reduce to B, comma C. So there's my point S. Now we're going to do the same thing for point T, because T is also a midpoint. So I'm going to do the midpoint formula, this time using C and B. So I'm going to take my X values, so 2B plus 2A over 2. Remember, midpoint is cut in half. And then 2C plus 0 over 2. Okay, so this 2 can be divided by both. 2B plus 2A over 2, comma, 2C over 2. So that's going to reduce to B plus A, comma, C. All right, so there's the midpoint, or there are the coordinates of point T. So I found the two coordinates. Now what I'm going to do is find the slopes of each of these lines. So we're going to start off, we're going to find the slope of segment ST. So to do that, you're going to take, remember the slope formula, take the points from S and T. We're going to subtract the Y coordinates. So I'm going to do C minus C over B plus A minus B. So C minus C is 0 over, notice a B and a negative B cancel out, so I have 0 over A, which is just 0. Okay, now, which you should look at your picture, you should have gotten out 0, right? Because a horizontal line has a slope of 0. Now we're going to find the slope of segment AB. We're going to do the same thing. The slope of segment AB. So again, I'm going to subtract my Y coordinates, so that's 0 minus 0. Now I'm taking the points from A and B, and then 2A minus 0. So I get 0 over 2A, which reduces to 0. They do have the same slope, so we have shown that the lines are parallel. So we're going to say segment ST is parallel to segment AB because their slopes are equal. And you're done with your proof. So a lot of coordinate proofs are going to be showing the work, doing the work for it, and then making your statement at the end, which verifies the work you did above. Okay, let's try another one of these. Okay, this time we're going to write a coordinate proof to show that triangle ABX is congruent to triangle CDX. Okay, so if I want these triangles to be congruent, I have to use either side, 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 or side, or angle, side, etc. So here's what I would do to try to figure that out. If you notice in this picture, you have vertical angles right here. Okay, so I would start with that right there. So we know we're going to use one of the ones that has an angle in it. So we're going to say that angle, let's see, what is that? AXB is congruent to angle CXD because vertical angles are congruent. Okay, so we're going to start with that. So I'm going to put an A here so I know that I have an A. Now, if I can show another pair of angles are congruent here, then we'll have two angles and we'll just have to find a side. So it looks like these two lines right here, AB and CD, they look parallel, but we have to make sure that they are parallel. So if we know that they are parallel, then we have this Z situation, right? Where you have those alternate interior angles. So let's see if AB and CD are parallel. So let's find the slope of those lines. So the slope of segment AB would be, I'm going to take AB y coordinates, so B minus 0 over 0 plus x minus 0. So I would get B over x. That's the slope of AB. Now I'm going to do the slope of CD. So I'm going to take the y coordinates, so B minus 0 over A plus x minus A. That's equal to B over, notice A minus A cancels, over x. Okay, so those lines are parallel. So let's say that. So segment AB is parallel to segment CD because their slopes are equal. Okay, and so because those lines are parallel, now we know that those two angles inside that Z are congruent. You also could have done the other angles, the angle at A and the angle at C, but we only need one pair, so let's just do one pair. So angle B is congruent to angle D because the alternate interior angle theorem. Okay, so there's another A. So I have two A's in this one. Now, I just want to say, you could have, once you said those lines were parallel, you could have done the Z this way. And if you did that, then you also know those are congruent. That would work as well for alternate interior angles. It doesn't matter how you do it. You only need two pairs of angles. So just pick two and then move on. So let's label this again. So we had our vertical angles. We knew that those lines were parallel, which meant alternate interior angles were congruent. So now what we have left is we need to show a pair of sides congruent. So you don't necessarily know which sides are congruent, so I'm just going to go by looking. It looks like A, B, and C, D are congruent. Technically, it doesn't matter which ones you pick, because if they're telling us to prove the triangles are congruent, they obviously have corresponding sides that are going to match. I'm going to pick A, B, and C, D because I think their coordinates are going to be a little easier to work with. So to be able to prove that those sides are congruent, we need to know the distance of them. So we need to find the length of AB. So I'm going to subtract the x coordinates. So we have 0 plus x minus 0 squared plus b minus 0 squared. Okay, the zeros go away, so I'm just left with x squared plus b squared. All right, so that's the length of AB. Now we need to find the length of CD. So the length of CD equals the square root of, we're going to subtract the x values. So a plus x minus a squared plus subtract the y values, b minus 0 squared. A minus a goes away, so you're left with x squared plus b squared. So that's the length of CD. Okay, so we just showed then segment AB is congruent to segment CD. So there's our side. Let's go back up to our picture so we can look at this. So that means we just showed those sides are congruent. So now we can say that the triangles are congruent. So triangle ABX is congruent to triangle CDX by angle, angle, side. And there's your coordinate proof. So this is very similar to a two-column proof. You're just going to have to do like slope formula in the middle of it and distance formula in the middle of it, and that counts as what you're proving to be true. So once you show me with the distance formula that A, B, and CD are equal, then you can just say it, that those sides are congruent to each other. So once you have all the information you need, then you can say triangles congruent. Okay, the last one, we have the Bermuda Triangle is a region formed by Miami, Florida, San Juan, Puerto Rico, and Bermuda. The approximate coordinates of each location, respectively, are, so they tell us what those coordinates are. We're going to write a coordinate proof to prove that the Bermuda Triangle is scalene. So the biggest thing on this one, we're proving that it's scalene. So if we want it to be scalene, we need to show that all the side measures are different. And to be able to find those side measures, we're going to do the distance formula. So MB is equal to the square root of. Okay, so I'm going to do this on my calculator. 33.37 minus 25.8. That's 7.57 squared plus 64.68 minus 80.27. That's negative 15.59 squared. Okay, so let's see what that gives us when we do both of those. So the square root of 300.353, and what is that? Whoops. Which is approximately 17.3. Okay, so that's the length of MB. Now we're going to do the length of MP. So square root of, so we're going to subtract the x's. So 25.8 minus 18.48 is 7.32 squared plus 80.27 minus 66.12 is 14.15 squared. Then I'm going to square both of those and add them together. And that is 253.8049. And we'll see what that is as a decimal. Approximately 15.9. And then we have one more, BP. So I'm going to subtract the x's. So 33.37 minus 18.48 is 14.89 squared plus 66.12 minus 64.68 is 1.44 squared. Then I'm going to square those and add them together. And I get 25.9857. Make sure that's right. No, that wasn't right. Thought that wasn't right. Should be 223.7857. So now we're going to square root that, and that's approximately 15.0. So we just showed all three sides are different. So that means the Bermuda Triangle is scalene because all the side measures are different. And so on that one, that's your coordinate proof. You're just showing me how you're coming up with that, and that is by doing the distance formula to show that all the sides are different. And I'm hoping all those side measures are correct since I'm doing it up here quickly with my calculator. So you can correct me if I missed one of those. This is your homework assignment. And if you have any questions, you're welcome to message me on Canvas. Ask people around you, double check your notes, use all the resources that you can to make sure that you are understanding this. And next time we're going to do a review over chapter 4 to get ready for our test.